Hello, I'm David Garrett, Group 65, and I'm going to tell you about the game AI I worked on involving neural networks. So, a little background on the game. It's called Cupo. Made it a few years ago in JavaScript. It runs in the browser. You can see a screenshot of the gameplay on the right. You got your units here: shots, bombs, turn counter, scoreboard. Um, and that's it. And here's where it's hosted. So some notes on the previous work I did on the AI. I started off with a rigid scripted AI, which gives very predictable behavior. Um, and I later implemented a basic like neural networks AI using reinforcement learning. And this semester, I wanted to improve on that. So this is the library that I built on. It's called ConvNet.js. Which lets you do convolutional neural networks in your browser. I didn't use those. I used the reinforcement module called DeepQ-Learning, which is included in that library. Um, and of course, we know what reinforcement learning is. You try there's kind of a trial and error process, and you try to maximize your average reward collection. Um, if you're interested in this topic, you may want to look at this paper, the Atari paper, which was published like 2014 or something. This library, ConvNet, is no longer actively maintained, but it still works. So these are the results that I got previously. You can see the number of games I trade, the win loss record, with ties in the middle here, and the win loss plus minus. So you can see maybe like at the end the network might have been really getting somewhere. It kind of looks like it. So the the data that the network would take in was 218 inputs, numerical inputs, of course, ranging from 0 to 1, which represented the complete game state, or at least a representation of the game state. Um, and this was accessed programmatically with no computer vision. So the hidden layers were just two small hidden layers, 75 neurons apiece with ReLU activations, and the output was 7 neurons representing the actions that the units could take, with the regression activation because the library was giving me warnings when I tried to have it use softmax. And of course, since it's reinforcement learning, there's really no training data, it's just generated through simulation. So my progress this semester was that initially I did set up the like a neural AI versus neural AI, as I mentioned in my update, but eventually I realized I had a lot of issues to deal with, so I went back to the neural AI versus the random moves. So one of the first problems I wanted to solve was persistence of the networks, so that they would not be lost when the page was closed. At first I had them stored in local storage in the browser, but that was starting to overflow because storing a network actually can take some storage, more than that would take. So I had to send them to the server, um, and I ended up storing both the network weights and the net's experiences to the server, and bringing them back when the page is reloaded. So at first I tried to crank up the learning rate to make training go faster, but when you do this, it turns out sometimes the model will kind of explode. Loss will go to infinity, and your backpropagation math obviously will not work well, and you'll get not a number of errors. So I had to set my alpha to 0.001 and decrease it as the model gained more experience. And by doing that, I got these results. So I wasn't able to train quite as many games as last time, and I'll touch on why in a minute. But you can see this is like tracking epsilon after this batch, and it goes down, and I'll talk about that in a minute. So here's the data. The lessons that I learned was that epsilon is a curiosity parameter. I mean, we kind of learned this in class. It's the it's the probability that the model is going to take a random action instead of acting according to the learned policy. Some terms related to epsilon: burn-in is a time during which the policy is ignored and it just acts purely randomly but accumulates experiences. The learning steps total is kind of like the old dog age, you could call it. It's the age of maturity for the model, where the model will mostly exploit the learned policy rather than exploring new possibilities. And this is when epsilon reaches its minimum. So one of the big takeaways from this project was that simulations can take a long time. And if possible, you should probably decouple them from visual rendering. So I'm going to kind of jump down here. Better graphics are, they may be great for making the game look nice, but they also can result in slower training, which is possibly one of the reasons I was not able to train as many games this time. So yeah. So this thing here, the saving the network early and often, another issue that I had that I feel done for was that I lost trained data many times because I did not make sure that my persistence mechanism was working of sending it to the server. So that was a long and painful trial and error process for me. And in the end, looking at the results, sometimes I think simpler is better. I did crank up this parameter of the network called temporal window because I wanted to more completely represent the game state. But that may have also been the reason why I got so many errors and had performance issues. And so sometimes it might just be better to keep it simple. And as for the whole idea of JavaScript with neural networks, it's kind of questionable because neural networks require high performance to some extent, and JavaScript is not a very performant language, which maybe is why the network is not supported, or the library is not being maintained. So if I were to continue this project, here are some things that I would do. I'm not sure that I will, because training a neural network to beat a game that I created isn't that interesting. But yeah, here's some stuff I would do. And as for the user API, the code is available in this GitHub repo. You can clone it if you want. And the game will be hosted at that website if you want to play it. And I don't know how you could apply the the code I made for these networks to anything else, but if you want to try, go for it, I guess. Thanks for your time. Have a good one.